Caleb, can you hear me?
Yes, is my microphone working?
Whoops, it is working. Awesome. You know if Henry's coming today?
I haven't heard that he won't be here.
All right. Let's begin because we have a lot to get through today. The first part of it is just review, so he probably doesn't need to see all of that. Last week we talked about parametric equations and taking the derivative and finding the arc length and all that. So here's a couple examples. For example, this one, it says, in the xy plane, the graph of a parametric equation, x equals 3t minus 1 and y is equal to negative 2t plus 4 between negative 5 and 5, is a line segment with slope what? Okay, so in this problem, what we want to do is we want to find the slope of that line segment. Okay, so remember when we took the derivative last week, let's see here, I need to find my pen. We found the derivative of a parametric equation is just y1 over x1. Now, most of the times when you take the derivatives, you're not going to get a line segment, but if you look at this, if you take the derivative of y, you end up with negative 2. You take the derivative of 3t, you end up with 3, and so you just end up with negative 2/3. Pretty simple problem there. The second problem, it says the length of the path described by the parametric equation x equals t squared and y is equal to 3t plus 1 between 0 and 2 is given by, okay? So which one of those is true? Good afternoon, Henry. How are you doing this afternoon?
I'm doing well. How are you?
I'm doing okay. Tomorrow I have to go off and do ACT testing up in Green Bay. Not exactly what I want to do on a Tuesday, but hey, I guess all the kids have to take ACT testing. Neither of you guys are juniors, are you? You guys are both seniors, aren't you? How well did you guys do on your ACT test last year? Awesome. A 30? That is very good. 30, you can start almost asking, you know, I mean, I know Madison is pretty tough to get into, but, you know, Madison, I think you have to get between like a 26 and a 28, and then you're okay. So 30, that is very good. Excellent job. Both applied to Madison? Wow, interesting. Have you either of you guys heard back? I know I have some friends that their son has heard back from Madison already. You, Caleb, congratulations. Henry, you have not heard back yet? Okay. Caleb, is that where you're going to go next year? Or did you have other places that you applied? Not sure yet? Okay. What other schools have you applied to? Oklahoma. Wow. Cool. So you guys have a lot of different options to where you want to go. Excellent. All right. So in this problem, let's see here. Oh boy, my dog is barking. Don't know if anybody's here, but I'll continue on. We said that the formula for this was just going to be, I think it was the square root of x prime squared plus y prime squared. I think that was our formula, if my mind is still there. So x prime, that's just going to be 2t squared plus y prime. Well, that's going to be 3 squared. So I would end up with 4t squared plus 9, the square root of that. So I think that would be my answer, and that would be letter A. All right, any questions on parametric equations? I was going to do a AP question Um, However, I don't think we're going to have enough time today. If we do have enough time, we'll come back to this problem. But it gives you a parametric equation and it says, is the horizontal movement of the particle to the left or to the right? Explain your answer. Find the x-coordinate of the particle's position. Find the speed of the particle. So you find the distance traveled. So those are all different, basically all the same type of stuff that we do with derivatives. It's just dealing with a parametric equation instead. All right. Oh boy, I'm gonna have to go tell my dog to be quiet. 1 second here. Hey. Not sure that's going to do it, but we'll see. All right. So today we're going to be talking about vectors in a plane. All right. Last week we talked about parametrics. This week we're talking about vectors. Did either of you work with vectors last year in your pre-calc class? Vectors are a whole different ball game. I mean, parametrics, vectors, and again, I'm going to show you what a vector is, and then I'm going to show you what type of calculus we use with vectors. And then next week, we're going to have polar coordinates. So we're learning all different, first we have parametrics, then we have vectors, and then next week we'll have polar coordinates. So all different ways to represent things, but you're still doing the same kind of stuff with them. You're doing derivatives and integrals and stuff like that. So let's talk about vectors. Two-dimensional vector, V, is an ordered pair of real numbers denoted in component form, and usually when you see the brackets that look like this, you're thinking of a vector. The number A and B are the components of the vector. The standard representation of a vector AB is the arrow from the origin to the point AB. The magnitude of V, denoted by the absolute value of V, is the length of the arrow, and the direction of V is the direction of which the arrow is pointing. The vector 0, 0 is called the zero vector, has zero length and no direction. So, and there's all different things that you can do with vectors. You can do vector addition, you can do product multiplication, you can do opposite vectors, and a magnitude vector. This one is the most important because we'll be using this a lot. But for example, if they ask me to add two vectors together, all you do is you add the first terms together, you add the second terms together. Super easy to do vector addition. If you want to multiply a vector, you can multiply a number by a vector. You just multiply each term in the vector by that. Opposite vector is just multiplying by -1. Now, a magnitude vector, this one's the important one. The magnitude or absolute value of the vector AB is the non-negative real number, square root of a squared plus b squared. Okay? And where does that come in when you think about it? Isn't that, if I had a triangle, and let's just say that this is a vector, and this is my arrow here, isn't this a squared, b squared, if this was c, and we're trying to find the magnitude, or this value right here, isn't that a squared plus b squared equals c squared? And then if I just took the square root of this, this gives me my c value. So that's basically where it comes from. If you're looking for the length of the hypotenuse, or they call it the magnitude. Okay, so here are some examples. Perform the operations on the vectors. Okay, so let u equal -1, 3, v equal 4, 7. Find the following. 2u plus 3v. Okay, I'll give you a couple seconds. Work that out. What do you get for 2u plus 3v? And you can write it on the board or put it in your chat box, or you can just say it. What would you get there? 1027. I agree. Is the correct answer, right? How about u minus v? What would we get there? Caleb, are you okay with the 1027? All right. -5, -4, I agree. And what is this? 1/2, absolute value of 1/2 u. Okay. So if I did this problem, first thing I would do is I'd do the 1/2 times the u. So it would give me -1/2, comma, 3/2. But remember, it's just positive. So this is just going to be the square root, since this is the magnitude. This is just going to be 1/2 squared plus 3/2 squared, which is 1/4 plus 9/4, which is 10/4. So the square root of 10/4 would be my answer, which I could write as, could I rewrite this as 1/2 square root of 10? Would that work? I think that works. If I simplify it down. It is not a point. That is correct. The magnitude is not a point. It is the distance of the, I would call it the hypotenuse, but it's the distance of the vector. And here are the answers. This is the work that they do. No, the other two you want to find the distance. The other two are just points when you're adding two vectors together. This is the only one that they were asking for a distance, the magnitude or distance of the vector. The other ones, you're just finding the vector.
So we know it was asking for distance because it was an absolute value?
Right, exactly. Yep. As soon as it's in the absolute value symbol, then it's asking for a distance, correct.
Okay.
Yep. All right, now, the direction angle of a vector, the direction angle, and this is just, I mean, realistically, you won't have to do any of this stuff when you start dealing with the calculus part of vectors. They don't ask you to add vectors together and all that kind of stuff. I'm just trying to review vectors so you kind of understand a little bit about vectors. The direction angle of a non-zero vector v is the smallest non-negative angle theta formed with a positive x-axis as the initial ray and the standard representation of v as the terminal ray. So if I asked you here, it says find the component form of the vector with magnitude 3 and a direction angle of 40. Okay, so if I wanted to draw that out, okay, 40 degrees is about like this, isn't it? So this is about 40 degrees. And the magnitude of 3, so this would be 3 here. That would be the vector with the magnitude of 3 and a direction angle of 40. So that would be my vector there. Okay. Now this is where it gets a little bit interesting, because they're going to ask us how to find x and y. So this is my x value, this is my y value. Can you tell me how to find x and y using sine or cosine? Because that's going to help you figure out a lot of different things today. So if I wanted to figure out what x would be in this problem, how would you do it?
If you take the cosine of 40 and then multiply it by 3, you'll get the x value, and then the sine of 40 multiplied by 3 will give you the y value.
All right, and that helps us. You'll see why it helps us in just one bit. All right, so here, okay, so it says the component of the vector found trigonometrically are x equals 3 cosine of 40 and y equals 3 sine of 40. Exactly what you said. So if you wanted to find this point, no, I can't go backwards on this. I hate. Right. So if I had this vector here, and this was 3, and this was 40, and I wanted to find this point right here, this point, you already said that it's going to be sine of 40 times 3, comma, and then 3 cosine of 40, right? I think it was cosine of 40, wasn't If I wanted to find the x value, isn't the x value cosine? Yeah, that would be cosine of 40. And then if I wanted to find the y value, that would be 3 sine of 40, right? Because this is my y value. Sine is opposite over hypotenuse of this. So my x value is going to be 3 cosine of 40. And my y value is going to be 3 sine of 40. And that would be my vector. So if they gave me a magnitude and an angle, I should be able to find the vector representation for that. And that's just that point, right? And you could have worked it out to decimal point, but we don't usually do that. All right, so now, all right. So that was just a real quick review of vectors. Here is the calculus of it. And it doesn't, once you know derivatives and all that, it doesn't really change much. So the position vector is just x of t, y sub t. The velocity vector would be just the derivative of x, derivative of t. Thus, the particle's speed is the magnitude, okay, so it's just the absolute value of v. And then the particle's acceleration is the second derivative, just like it would be with anything else. The particle's direction of motion is the direction vector, v over v prime. Okay, these two are the most important that we're going to know, because the rest of them are pretty easy. Position, velocity, acceleration. Those you should know, because position is just p of t. Velocity is the first derivative. Acceleration is second derivative. Okay, so those should be very normal to us. All right, so let's try an example here. It says a particle moves in a plane so that its position at any time t is greater than 0 is given by sine of t, t squared over 2. Find the position vector of the particle at time t. Okay, well, if you think about it, wouldn't that just be position function? Wouldn't that just be sine of t, comma, t squared over 2? That would be my position function. Not much work to do there, is there? Then if they ask me for the velocity vector, okay, well, that's just the first derivative, right? So that's going to be cosine of t, and then 2t, is it the 2's are, oh no, 2t, wouldn't that just be t? Because the 2's are going to cross out there, I think. And then find the acceleration of the particle. Okay, well, that's my next derivative. So that's going to be negative sine of t and 1. Describe the position of and motion of the particle at time t is equal to 6. Now this is where, okay, these three very simple calculus problems: position, velocity, acceleration. Okay, but what about these? They want to know, describe the position and motion of the particle at time t is equal to 6. Well, the position, isn't that going to be sine of 6? And isn't or sine of 6, and then what is that, 36 over 2, which is 18? The velocity is going to be, what is that, cosine of 6. Acceleration, I mean, I just plugged 6 in and they didn't ask me for all that kind of stuff. But now, what would the distance, or if I asked you, what is the displacement and distance? Oh, well, I think we have a different problem on this one. So now, the motion of the particle at time t is equal to 6 is a little bit more complicated. Okay, so if we take a look at the graph of this, okay, so here's my answers, boom, 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 and then here is, if you take a look down here, this is the path of the particle, And can you graph these with your calculator? Okay, can you graph a vector on your calculator? And I would say that if you go to your mode button, just like we did with other functions, you're not going to find a vector function on there. You're going to see parametric, polar, but there's really no vector problems on there. But you definitely can graph these in parametric mode. Okay, so if you want to graph this, you'd still be in parametric mode because x equals sine of t, y is equal to t. That's parametric. So you can graph this, and you should get this graph out. Okay, so that's just a little bit of the calculus that goes into these types of problems. So now let's say that we have a particle moves in the plane with a position vector, sine of 3t, cosine of 5t. Find the velocity and acceleration vectors and determine the path of the particle. Okay, so this is a position. So what is my velocity vector? What is my acceleration? Okay, what are those two? What are those two answers? Three cosine 3t. So this is velocity. So that's going to be 3 cosine 3t, comma, and then negative 5 sine of 5t. So basically, you're really practicing taking your derivatives, right? I mean, that's what this whole thing down to. And then the acceleration, that's going to end up being negative 9 sine of 3t, comma, negative 25 cosine of 5t. Okay, so not very hard to find acceleration and velocity and acceleration. And here are the two. And if you put it in parametric mode, this is what your graph is going to look like. Kind of a crazy looking graph there. But you can graph them out just by using parametric mode. All right, now, this is where it gets a little bit more complicated. Displacement and distance traveled, because they're always going to ask you for these things. I mean, it's too easy to ask for position, velocity, and acceleration. But if they ask you for the displacement and distance traveled, right? So take a look here. It says, suppose a particle moves along a path in the plane so that its velocity at any time t is given by v of t, v of 2t, where v1 and v2 are integrable functions of t. The displacement, okay, the displacement is going to be from a to b, integral of v of 1, a to b, v of 2. So not too hard, right? The displacement is not bad. Okay, but remember, we did talk about the difference between displacement and distance, right? Distance is, displacement is how far you are from where you started from, and distance is how far you travel total. So let's say I gave you a number line and I said, okay, let's put a couple more numbers on here, 0, 1, 2, 3, 4. And I said, I started at 0, I went to 3, then I turned around and I came back to 1. Well, my displacement is just 1, because that is the distance from where I started to where I stopped. But my distance now happens to be 3, 4, 5. Okay, so the distance you travel and the displacement, two totally different things. And some kids, they give me the same answer for both, and it's like, it's not the same. Okay, so displacement is just an integral of each one, and the distance traveled is the absolute value of the velocity, and that turns out to be the integral of the square root of v1 of t squared plus v2 of t squared. So this basically is giving you, it's that a squared plus b squared equals c squared. So it's giving you the distance. So let's take a look at an example. Okay, it says a particle moves in the plane with a velocity. Okay, so they're giving me the velocity vector. At t is equal to 0, the particle's at 0.15. Okay, find the position of the particle at t is equal to 4. And what is the total distance traveled by the particle from t is equal to 0 to t is equal to 4? I am going to let you guys work on this for a little bit and see what you guys come up with for answers, okay? Yes, you can use calculators on this type of problem. So I'm going to turn off my mic. I'm going to just let you work, see what you get for answers, okay? All right, let's take a look at this. What did you get? It says find the position of the particle at t is equal to 4. What did you get for that answer?
I wasn't able to solve A, but I did figure out B.
And what did you get for B? Oh, you didn't solve A.
40. No.
All right, so let's go. Let me see if they were wanting you guys to use a calculator on that or not. I'm looking at that. I'm thinking that'd be a pretty tough problem to do without a calculator, but that's t squared. Well, maybe it can be done without a calculator. Let's find the position function at t is equal to 4. Okay, so that means I just have to take the integral of t minus 3 pi cosine pi t. That's pretty interesting integral. And then the integral from, or 2t minus pi sine of pi t. Okay, so let's work on this one first. I might rewrite this as integral t minus the integral of a 3 pi cosine pi t. Well, if we take the derivative, I can pull the 3 pi out, can I? So I've got the integral of t minus 3 pi integral cosine pi t. 217, is that for number 1 or part B? That can't be for part B because part B is going to be just one number. All right, I didn't get that. Okay, so if I take the integral here, this is going to be t squared over 2 minus, and then cosine pi over pi t. If I take the integral of cosine, that's just negative sine, isn't it? Oh, no, it's just sine. So this is going to be sine of pi t over pi, isn't it? And then I have 3 pi out in front. So those pi's are going to cross off. So I think just this value, I have t squared minus 2 minus 3 sine of pi t. And that's from 0 to 4, or at t is equal to 4. All right. So at t is equal to 4, so I just, let's see if I, so that's going to be 9 minus, I put 4 in there, 4 pi. Well, isn't that 0? Wouldn't that be 0 there? 3 times sine of 4 pi is just 0. So that's going to be 9. So I'm going to have 9 here. Does that make sense, how I came up with 9? And then from my next one, the next one, that's going to be, so that's going to be 2t squared over 2, so that's just going to be t squared, minus, what is that, sine of pi t? So that's going to be, that pi is going to go on the bottom, so that's going to cross out. So that's just going to be the integral of sine, that's negative cosine, so this is going to be plus cosine of t. I think this is the integral. Oh, that's going to be a pi in there. Sorry about that. You still have to have that pi. Okay, so that's my integral. So I'm going to plug in 4 here. So if I put 4 in there, 4 squared is 16. Plus, if I put 4 in here, 4 pi, well, cosine is like this. So that's 2 pi. Keep going, 4 pi would be at 1. So this whole thing here would be 1, I believe. Unless I mess something up here. Oh boy. So if I put 4 in there, did I mess something up here? Because
I don't think it's 9, because sine 4 pi is 0, so it'd be 8 minus 0, not 9. At least that's how I got it. Because if you
here,
put 4,
oh, gotcha. And then sine, so that's going to be 0. Oh boy. Let's see here. Okay, and then how did you get 6? Did you get 17 for this next value? 8, 17? And then, since this is my value here, this is where it started, so I have to add 1 here, and I have to add 5 here, don't I? So shouldn't my answer be 9, comma 20, 22? I think this one is, I don't think it's 17 though. I think I messed something up here. T squared, that would be, I think I messed something up here because the book has 16 here for this value, and then you add 1, you'd end up with 21. I don't know what I did wrong here taking the integral. Can you guys see what I did wrong here? So I've got square that, so that would just be t squared, right? And then if I took the integral here, that's going to be pi, that's going to be plus cosine, negative cosine, so that's going to be 2 divided by pi. So that to me is correct. Cosine of pi t, isn't it? And then if I put 4 in there, 4 pi just gives me 1, doesn't it? So that's 1, 16. I still get 17. I don't know how the book came up with 16. So then if I add 5, I'd end up with, or add 1 here, add 5 here, because remember, it says the particle started at 1, 5. That would be my answer then. Okay, so don't forget to, since the particle started at 1, 5, we have to make sure that we add the 1 to our t value, or to our x value and our y value. Does that make sense? Okay. All right, so now the second part, let me get rid of this. So the second part, we have what is the total distance traveled by the particle from 0 to 4? Okay, so if I want to find the total travel, I'm just going to go, whoops, my marker's turned off here. I'm going to go 0 to 4, and then I've got the square root of, and then I'm going to take the square root of the velocity, the absolute value, and square it. So this one you're not going to be able to use, you're not going to be able to do it by hand. There's no way that you could do this one by hand. So you're just going to have t minus 3 pi cosine pi t quantity squared plus 2t minus pi sine of pi t quantity squared. And you should end up with, if you do it correctly, 33.53 for an answer. But you got to make sure you plug this into your calculator correctly, because if you don't, you're going to get a way off answer there. All right, so total distance and position. So here's, boom. Now, let's take a look. This is a problem off an AP test. Okay, it says at time t, a particle moving in the xy plane has a position x, t, y, t, where x and t are not explicitly given. So t is greater than 0, dx dt is 4t plus 1, dy dt is blah, blah, blah. It says find the speed of the particle and find the acceleration vector of the particle at time t is equal to 3. So that should be a pretty easy one to do. Okay. And then find the slope of the line tangent to the path of the particle at time t is equal to 3. That one shouldn't be too bad. Find the position of the particle at time t is equal to 3. Then find the total distance traveled. So now, this problem right here basically puts together all of the things that they'll ask you for dealing with a vector question, okay? So I am going to let you guys work. This is a calculator problem. So I'm going to let you guys work for a little bit and see what you come up with for the answers, okay? So take some time, work that out, see what you come up with. All right. Let's work through these one by one. Did either of you get an answer for the speed of the particle at time t is equal to 3?
I have a quick question.
Okay.
If we are using radians and we say the sine of 9, because it's sine of 3 squared,
Mm-hmm.
are we literally putting sine of 9 into our calculator?
Okay, so are you doing part A? What part are you working on?
Yeah, well, I've completed part A and B, but I'm just making sure that I did it right.
Yeah, if 9 is the number that you're using, you're definitely dealing with radians. What did you get for an answer for part A?
0.03?
Oh, not even close. All right, what did you get for part B?
Well, there's like 2 parts to part A.
Oh, I'm sorry. Right. What the speed you came up with 0 point something?
0.03, yeah.
And what did you come up with for the acceleration?
4 comma negative 7.7.
Okay, 4 is correct. I didn't get
Okay.
negative 7.7. I came up with negative 5.466. Okay,
Okay.
so now let's take a look. When you did when you did speed, what did you do? Because if I was doing speed, it says find the speed of the particle at time t is equal to 3.
Mm-hmm.
All right, we're dealing with. So what I did is I said, okay, speed is equal to x prime squared plus y prime squared. Now, do I have x prime? Do I have y prime? Sure looks like it, doesn't it?
Oh, okay. Yeah.
So I'm just going to go 4t plus 1 squared plus, what was that, sine of t squared for my speed. And that is how I came up with, and I came up with 13.006.
So how do we know when to use that compared to the parametric derivative rule of the derivative equals x or y, it equals y derivative over x derivative?
For Can you guys still hear me?
It just disconnected and it kicked Henry out, I think, as well.
All right, because I have a little blue dot up here and it says you are still reconnecting. Please wait.
Can you hear
Reload the
me?
session. Okay, can you guys still hear me? All right, I don't know if I know it's not my internet because my internet seems to be working fine. Because usually when something happens like that, I usually just type in msn.com and see if my if that comes up, and if it comes up, it's like, okay, my internet's working, but I definitely got kicked out there, and now it looks like my internet it just keeps rolling. Okay, I'm going to put the work for that problem on because I don't know if I'm going to get kicked out or not again. So here, this is the work that was given for that AP question. Okay, speed, acceleration, 7 something, didn't you? I'm just going to plug this into my calculator because that's just a second derivative, right? Particles at time t is equal to 3. Find the acceleration vector at time t is equal to 3. So the sine is cosine t squared times 2t, right? So I'm looking at 3. So wouldn't that just be 4 here? And if I put 3 in here, wouldn't this be 6 cosine of 9? And obviously you would need a calculator there. So let me, I'm just jumping into my calculator real quick. So I'm just make sure I'm in radian mode. And then I'm just going to type in 6 times cosine of 9, 6 times cosine of 9, and I end up with negative 5 point. So yeah, I do get the answer. Do you guys still hear me? Yeah, I have a feeling this is the Blackboard's fault. I don't think it's my internet. Um, I think this is having some major issues. Okay, Henry, did you see how I came up with negative 5.467? Okay, so I don't know how you came up with negative 7 something on there. Okay, so you got okay, because before you said you had negative 7 on there. So now if I wanted to find the slope, and I'm not sure if I want to jump back and forth because it seems like that's where I'm having some problems. Okay, so part B, it says find the slope of the line tangent to the path of the particle at time t is equal to 3. Well, we already know the derivatives, don't we? So in this problem, it's just y prime 3 over x prime 3, and we should end up with 0.031. Fairly easy question there.
Mr. Schenker, I have a question.
Absolutely.
So the derivative of a position graph is the velocity, right?
Correct.
And its absolute value is the speed.
Correct.
So shouldn't the slope be the same thing as the speed?
No, because when you're dealing with a vector, the vector, and that's where it gets a little tricky. The vector. Remember when we talk about a vector, and if we have that point here, so this is our point. The speed or magnitude is this distance right here. So that's why you end up with that a squared plus b squared equals c squared. This is
right.
the magnitude of and that's why we use the square root on that problem. That's where it gets a little bit tricky on those types of problems.
Okay.
Yeah. And then part 3, I don't remember what part 3 was. I think part 3 was displacement, wasn't it? Oh, it doesn't even want to go to the previous slide anymore. Oh, there we go. Yeah, I think this is a Blackboard issue right now because it seems like my computer's working. It seems like Blackboard is having some problems here. Okay, so then it says find the position of the particle at time t is equal to 3. All right, so if I want to find the position of the particle, all I'm going to do is I'm just going to take the integral from 0 to 3, and it started at 0, so just take the integral, and I should end up with 21. And I don't remember what the next question was, and All right. I think this is going to be it for today because I think Blackboard is having some major issues here. I can't even go forward and backwards on my slides anymore. Let me see if I can, yeah, gone. All right. That's going to be it for tonight because I think Blackboard is having some major issues tonight. All right, you guys have a great week. Sorry about that. No control over Blackboard sometimes. Have a good week, guys.